You'll learn that lists are very similar to arrays, but can be resized. This makes lists very useful for storing data when you don't know how many items you will need to store at the time that you instantiate the collection. I'll show you how, despite this difference, the principles of coding with lists and arrays are actually very similar. And along the way, you'll get your first taste of searching for items in a collection. In the last module, I developed some code that read the first 10 countries from a CSV file. But what happens if I want to read all the countries from the CSV file? Can we do that? Well, there's a problem. Look at the code in the read first in countries method that instantiates the array to hold the countries. I instantiate the array by saying how big it's going to be, that is, how many elements it's going to hold. That's fine when I've decided in advance that I want 10 countries, but if I want all the countries, and the code is reading the CSV file line by line, then you won't know how many countries there are until the code reaches the end of the file and discovers that there are no more countries. But that's too late to instantiate the array because you need to put the countries in the array as each one gets imported. So in this situation, you have to instantiate the collection before you know how many elements it will hold. How can you do that with an array? Unfortunately, with arrays, the answer is you can't. And that is the fundamental weakness of arrays. Arrays have a fixed size. You have to specify, when you instantiate an array, how many elements that particular array holds. And then you can never change that size. That's great if it's a collection of, say, names of the days of the week or months of the year, when you know up front exactly how many elements you'll need. But in most cases, when you're reading data from an external data source, you don't know how many elements until you've finished reading the data. And that is where list of T comes in. List of T is very similar to an array, except that it doesn't have a fixed size. You can freely add as many elements to it as you want, whenever you want. In a short while, I'm going to modify the main countries demo to actually read all the countries using a list. But first, I'll show you the basics of list coding by creating a list of days of the week, just as I did for arrays at the start of the course. So I have an empty console app. I want a list of strings to hold days of the week. So I declare the variable as list of string, and it's going to equal new list of string. And notice that the name of the type that this is a list of, string in this case, goes inside angle brackets. Similarly, if I wanted a list of integers, I'd say list of ints equals new list of int. On the right-hand side of the equal sign, you can see the standard C# constructor syntax. There are no parameters to the constructor because, unlike an array, list of T always starts its life empty. You have to dynamically add the elements to it after you've instantiated it. The name of the list type obviously follows a very different syntax from arrays, where you'd just say something like string square brackets. That's because arrays are part of the .NET runtime and therefore have their own special syntax in C#. List of T, on the other hand, is just an ordinary type and so follows the normal C# syntax for newing up objects. And as a general rule, lists are more flexible than arrays, but arrays will usually give you simpler code. So as a rule of thumb, I personally will use a list instead of an array only if it's a situation where I can't use an array. So far, I have an empty list of string. I said I want to store the days of the week in it, so I need to add items to it. And I do that very simply by calling a method called add. So I say days of week dot add Monday, days of week dot add Tuesday. You get the idea. Using list.add to populate a list is the most common scenario. I will mention though that if you know before you instantiate a list what items it needs to contain initially, then you can still use a collection initializer. I'll just paste in the code to show this. That's almost identical to the array initializer that you saw at the start of the course, with the items to go in the list inside curly braces. There's a minor difference that with lists, and indeed all other collections apart from arrays, you have to explicitly new up the type on the right-hand side of the declaration, which, remember, was optional for arrays. By the way, I'm sure you've realised that a fixed size collection like days of the week is much more suited to an array than a list. This code is just to show you in principle how to work with lists. Also, this collection initializer makes it look like you're instantiating the list with data in it, but don't be fooled. It's just syntactic sugar. Under the hood, the compiler will just turn the initializer into code that instantiates an empty list and then repeatedly calls the add method to add the items you've specified. Now I want to talk about this angle bracket syntax. If you're familiar with generics in C#, you will recognise that angle brackets marks list of T as a generic type. If you're not familiar with generics, and this is a beginner's level course, so I know some people watching won't know about generics, then don't worry about it. Just think of it as a general principle with collections that you tell the compiler what item will be stored in a collection by putting that type in angle brackets. That applies to all the commonly used Microsoft collections, except, of course, arrays. And if you're wondering why I keep calling the type list of T, the answer is that the list can, of course, be a list of anything. But if you're talking about the list type generally, without wanting to specify any particular list, then you use a convention in generics that T refers to an unspecified type. And if you need to look up the list in the Microsoft documentation, you'll see that list of T is the name that Microsoft calls it in all documentation. Now it's time for the real demo. In the last module, I created a demo that displayed the first 10 countries imported from a CSV file. I'm now going to modify that demo so that instead of importing just 10 countries, it imports and displays all the countries. So you're looking at the CSV reader type from before. Recall that CSV reader is responsible for reading the countries. I haven't yet changed any of the code, except that I've changed the namespace name to read all countries, which is what I'm calling this demo. The method I need to change is read first n countries. This method obviously now needs to read all the countries, so first up I'll change the method name to reflect its new purpose. And because I'm importing everything, I no longer need an argument to say how many countries to get. Also, obviously I need to return a list of country, not an array of country. And the same for the countries variable. This line, countries I equals, needs to change too. It's currently trying to replace an element of the list. Rather conveniently, the syntax for replacing elements is exactly the same for the list as it is for an array. So this line is syntactically correct, but it's not going to work here because the list starts empty, so there are no elements to replace. Instead, we have to add each country to the list, growing the list as we do. I'll just do that. And the loop needs to carry on to the end of the file, not stop after n countries, countries. This is a while loop, not a for loop. The logic is based on a feature of streamReader.readLine. ReadLine will return null if it finds that it can't read any more data because it's already reached the end of the file. So the idea is we just keep reading until ReadLine returns null. And that's reading the countries sorted. I should also check out the main method, which displays the countries. Visual Studio is flagging a compilation error here. That's because countries is declared as an array of country in this method, but readable countries returns a list of country. Let's fix that. And no parameter required. That's fine now. And the key thing to notice here is that I don't need to change anything in this for each loop. For each works exactly the same for enumerating list of T as it does for enumerating an array. And this is where perhaps you can start to see the beauty of collections. Even though different collections have different abilities, Microsoft has carefully designed them so that very often the same code works for every collection type. So, do you reckon we're done? Let's try it. Crash! Unhandled exception. Input string was not in the correct format. This is in the read country method at the line that tries to convert the population of a country to an int. What's the value that won't parse? Parts 3. Oh. That contains the string Africa. No wonder ints.parse can't convert that to an integer. How did that end up in the population field? We can see what's gone wrong if we look at the line this code is trying to parse. It's Egypt, and this is the problem I warned about in the previous module that we would encounter if we tried to read in more than 10 countries. Egypt has a comma in its name. Egypt, Arab Republic. And of course, string.split has split the name at the comma. That means we have 5 substrings, not 4, and the population is stored in parts 4, not parts 3. Clearly, we now need to fix the read country from CSV line method so that it can cope with this situation. Now, in the general case, reading CSV lines that may have embedded commas in the data is tricky. A proper solution would probably involve regular expressions. But to keep things simple, I'm going to rely on my knowledge of this particular CSV file. You see, I know that the name column sometimes has 1 comma in it, but no other field ever contains commas. So the only awkwardness we need to cope with is name getting split into 2. It's simple to identify when that happens because, as you've seen, string.split will then return an array containing 5 elements, not 4. So what we need to do is check how many elements we have in this parts array that's returned from string.split. How can you do that? The answer is that arrays have a property called length, which returns the number of elements in the array. So in principle, the solution is simple. Unfortunately, it also requires a complete rewrite of the entire read country from CSV line method. So I'll just paste the entire new code in. I split the line as before, and I declare the variables that will hold the various bits of data for the country. Now I use a switch statement based on how long the parts array is to separate out the case of the country being split up. And this, of course, is where you see the array.length property in action. If parts contains 4 elements, then it's exactly the same situation we had before. If it's 5 elements, then I know the country name was split up and I have to reform the name from the first 2 elements of the array, and also remove the double quotes that will have been surrounding the country name in the CSV file. And of course, now the country code is in parts 2, not parts 1, and similarly for the region and population. I also have a default case just to cover myself if there's something really weird in the CSV file that I didn't anticipate. After the switch statement, I pass the population into an integer and then return the new country. This time I'm using try_parse to parse the population to an integer. If the population is unparsable, try_parse leaves it as the default value 0 rather than throwing an exception. That actually does happen in the CSV for the country Eritrea, with 2 dots used to indicate an unknown population. In a real app, I'd probably want to handle that case separately, probably by making the population a nullable int. But here, that's a complication that isn't going to help understand collections, so I'll just run with, if the population is unknown, I'll leave it as 0. Now I think the program is ready to run. Let's try it. Yay! It works! As you can see, there are a lot of countries, and right at the bottom is that unknown Eritrea population. The program output actually does say unknown there. That's because I coded up the population formatter class to format a 0 population as the text unknown. I'm clever like that, you see. Before I leave the subject of counting elements, I just want to go back to this array.length property, which I used to query how many elements were in the parts array. Because there's something you should be aware of. Array is different from all other collections here. I think just about every collection has a property that will tell you how many elements are in the collection. But for almost all collections, that property is called count. Array is a rather strange exception in having that property called length. And in fact, I will just show you that. I'll go back to the main method, and just after I list the countries, I'll add code to display how many countries there were. Countries is a list, not an array, so I have to use the list.count property. I'll just run the code again. And wow, 217 countries. No wonder everything scrolls by so quickly whenever I run the code now. You've now seen how to build up a list by adding elements. Adding really means that you are appending items to the end of the list. You might wonder if you can also insert items in the middle of the list. And the answer is yes, you can. List of T features an insert method that works a bit like add, but it lets you insert the item anywhere you want inside the list. And by a strange coincidence, I've just noticed something that requires an insertion. I had a look through the list of countries that the sample displayed, and can you believe Lilliput is missing? Remember Lilliput? That country that Gulliver discovered 300 years ago. I believe he described it in a history book he wrote called, what was it? Gulliver's Travels. Yes, that's the one. Frankly, I just don't understand how the World Bank managed to leave Lilliput out of their data. But I feel a moral obligation to rectify that. So, just after the code has finished reading the countries from the file, I want to insert Lilliput. So, I'll define a variable to represent Lilliput. I'm not sure what the population is, but I've guessed 2 million. And now I've instantiated Lilliput, I need to insert it into the list. So, countries.insert Lilliput index, Lilliput. The first parameter, for which I'm passing Lilliput index, lets you specify the index where you want to insert the new item. Visual Studio is showing a syntax error because I haven't yet initialized Lilliput index, so that's the next task. And now I have a problem. I have roughly the code to insert Lilliput into the list, but where? What value do I set Lilliput index to? Let's think about this. The countries are stored in the list in decreasing order of population, and I'm saying Lilliput's population is 2 million, so that means I need to find the first country with a population below 2 million and insert Lilliput just before that country. How do I do that? Well, for a problem like this, I often turn to the MSDN documentation. You see, a nice thing about list of T is it has a pretty extensive set of methods to perform operations. Things like sorting and searching and copying. Just look at all those methods. Far too many to memorize, and definitely enough to make it worth checking to see if there's a method that will help when you have a new problem like this. And in fact, there is a method that does exactly what we need. Find index. Find index searches from the start of the list for the first element that satisfies a particular criteria and then returns the index of that element. So back to the code. What I want to say is Lilliput index equals countries.findIndex. X goes to x.population is less than 2 million. I should perhaps explain what I'm doing here because this is somewhat advanced C#. FindIndex takes as a parameter something called a predicate. A predicate is basically an expression that returns a boolean, true or false. And you can see the thing after this operator that looks like an arrow is basically an expression that returns true if X is a country with a population less than 2 million. And the syntax here represents what's known as a lambda expression. You can think of it as a quick way of writing an expression that takes whatever's on the left of this arrow and returns whatever's on the right. The way FindIndex works is it will run this expression against every element of the list in turn until it hits an element for which the expression is true. It assumes that's the element we're looking for and returns the index of that element. And obviously the predicate I've supplied here will test for a country whose population is less than the population of Lilliput, because that's what will tell me where to insert Lilliput in the list. Anyway, let's run the code. It says 218 countries, which is one more than there used to be, so that's good. And if I scroll up, yes, Lilliput is there, in the correct position between Gabon on just over 2 million and Latvia on just under 2 million. So, you can add or insert items to a list. How about removing items? Yes, you can do that too. And in fact, that's just as well, because a few minutes ago I had some very sad news. One of the reviewers of this course has just informed me that Lilliput is fictional and doesn't exist. I must admit I'm shocked by that news. I feel like the world I knew has collapsed around me. But if the land of Lilliput is fictional, then clearly I have to remove it from the list of countries. So let's type in the code. Countries.removeAt Lilliput index. No prizes for guessing what removeAt does. The parameter is the index of the item that you want removed. We know that's the correct index because that's the index that we just told the app to insert Lilliput at. Let's run the code. Looking good. 217 countries again. And if I scroll up, yes, Lilliput has gone. So that's how you remove items from a list. By the way, I do realise that this code looks a bit pointless. In real life, you're never going to deliberately insert an item and then immediately remove the same item. But in the context of this example, I figured that was the easiest way to show you how to remove an item. I just want to finish off with a warning about performance. You see, just because you can easily insert and remove items doesn't necessarily mean you should. Think about the action of adding elements. That just goes on the end of the list. Easy. But what happens when you insert an item? Everything after the insertion has to move down the list. Lists really do store their items sequentially in memory, so the data does have to get physically moved around in your computer's memory. Obviously, that's not a problem if it's a list of 5 items, or even maybe 50 items. But imagine a list that has 100,000 elements, and you insert an item near the start of the list. And it's the same logic for removing items. Because of that, I'd be careful about inserting or removing elements from a large list too often. In most cases, the best use for a list is simply to build up a collection by dynamically adding the items you need. In this module, you've learned about list of T, and you've seen that unlike fixed size arrays, lists are instantiated empty, and then you can freely add and remove items. So they are great solutions when you don't know at the outset how many values you'll have. But other than that difference, lists work in basically the same way as arrays for enumeration and lookup. I've also shown you how to check how many elements are in a collection and how you can search for an element in a list satisfying a particular criteria. And you've learned that although you can insert or remove items in a list, that can cause performance issues. Next up, you're going to look at the dictionary, a collection that is very different from arrays and lists, and has a very different typical use case scenario.